Hello dear students, welcome to SciMa Academy. This is Prema here. I hope all of you are doing very well. If you have not watched my previous videos, please go and watch my videos and subscribe to my channel. Those who have watched my videos, they know that I am starting with the chapter Circles of CBSE Grade 9. So I have posted the last video on terms and definitions of the circles. You will get an idea of what are the parts of the circle. So now I'm going to start with the theorems of the circles. Before actually starting with the topic of circles or solving problems in circles, you must be very well versed with the theorems of the circles. Okay, so if you don't know the theorems, they are the very important properties related to circles. You will not be able to solve the questions in circle. Okay, so first we have to understand the theorem, how to prove those theorems. Then we will start with some of the important questions of the circles. So let's get started. So I have started with the circles chapter of CBSE grade 9. If you have not watched my videos, please go and watch my videos. You will surely like it. And I've now started with theorems of the circles, which is very important part of the chapter before you actually start solving the questions on circles. Okay, so let's get started. So now I have in my previous video I have done two theorems. Okay, so now I'll be doing theorem 3. Okay, so theorem 3 is based on the perpendicular from the center of the chord. So let me draw a circle first. So if I draw a circle, so if I have, okay, fine. So if I have a center here, suppose this is a center O, and now this is a chord. So this is a chord. Okay, so here if I draw a perpendicular, so I draw a perpendicular. Okay, so here I can join this, okay, so maybe this, name it as A, B, and this is say D. Okay, here what the theorem says, the perpendicular from the center of the circle. Now this is a perpendicular, so we have a perpendicular here, so this OD is a perpendicular, so perpendicular from the center of the circle to the chord bisects the chord. Means what we need to prove? We need to prove AD is equal to DB. Okay, so the line which is coming from the center of the circle, which is perpendicular, which is given to you, we have to say that if this OD, which is a perpendicular, is bisecting the chord AB into equal parts. So basically we have to prove that AD is equal to DB, right? So here how do we go about it? So here first always write what is given. So here it's given AB is a chord, okay, and OD is perpendicular to AB. These are the two things given to you. Okay, and what you need to prove here? You need to prove that AD is equal to DB. Okay, so here again we will go with the congruency. Okay, see children, that's why you need to understand triangles chapter, congruency rules very well. Even that is applied here in circles chapter also. Okay, so how do we prove now? Here I take two triangles again, triangle AOD and triangle BOD. Okay, so what do we see here? One thing we see here is a right angle triangle, right? This is a right angle triangle, this is also a right angle triangle. So let's try to use RHS congruency. Okay, so let's see right angle. So we have a right angle here, angle ADO is equal to angle BDO. Both are 90 degree because they have given that OM is perpendicular to AB, so I can say this is 90 degree, this is also 90 degree. Okay, so this becomes our right angle. Now hypotenuse, yes, we have hypotenuse here, opposite to 90 degree we have the radius, opposite to 90 degree here also we have the radius, and they both are the radius of the same circle, so radius are same, right? So we can write OA is equal to OB, they are the radius. So this becomes our hypotenuse. and the side, which side? You see that OD is the common side. Okay, so we can write OD is equal to OD, which is the common side. Okay, so this becomes the side. So it's very clear that the triangles are congruent, AOD congruent to triangle BOD by RHS congruency. Okay, so once the triangles are congruent, we have proved, we can easily say therefore AD belongs to the triangle AOD is equal to BD or DB, which belongs to triangle BOD. They are equal by CP CT. Okay, so it's very simple. Okay, how can you prove that the line which is coming from the center perpendicular on the chord, how it bisects the chord? Okay, so this is the theorem. This is how we prove this particular theorem. Now coming to theorem 4, this is again based on the same concept of a perpendicular from the center to the chord. Okay, so here again I will quickly draw a circle. Okay, so here if this is the center, suppose this is a center, let's draw a chord. So this is say a chord, so I will join this, make a perpendicular and join this. Okay, so this is the center O. Okay, this is A, B, D. So here what is the theorem says here? It says that a line drawn through the center of the circle to bisect a chord. So here it is given that AD is equal to DB, because it's telling that the line which is coming from the center of the circle bisects the chord, that is AD is equal to DB. You have to prove it is perpendicular to the chord. Okay, it is just the converse of this theorem, converse of the previous theorem. Here what was given to us? AB is a chord and OD is perpendicular to AB, but it was not given it is bisecting. So we proved that AD is equal to DB, right? Now but in this they have given us AD is equal to DB. It's given that it is bisecting, but what we need to prove? We need to prove that whether these angles are perpendicular or not. That means we need to prove these two angles to be 90 degree. Okay, so this is a converse of theorem 3. This is converse of theorem 3. Okay, so here what is given? Here it's given AB is a chord and AD is equal to DB is given to us. So what we need to prove? Angle OMA is equal to angle ODB is equal to 90 degree. So basically we need to prove that this line is perpendicular on the chord. So we need to prove these two angles to be 90 degree. Okay, so again here we will go with the congruency. We will take the same triangles, triangle AOD and triangle BOD. Okay, so here what is given? We will see here quickly. We will see here. Okay, so we have a radius. So we have here OA is equal to OB, which is the radius. Okay, and we have also given, they have given AD is equal to DB. Again it is given to us. And the third side OD is equal to OD. If you see, this is the common side. Okay, is also common. So we have side, we have another side, we have third side. So therefore we can say the triangle AOD is congruent to triangle BOD by SSS rule. Okay, so once the congruency is done, we can easily say that, that's why angle ODA is equal to angle ODB by CPCT. Okay, so I have shown that here by CPCT these two angles are equal, but what we have to prove here? We have to show that these two angles are 90 degree. So how do we do that? So we know that, okay, what we know here, angle ODA plus angle ODB is equal to 180 degree. Why it is 180 degree? Because it is forming a straight line. They form a linear pair of angle. So linear pair of angle always add up to 180 degrees. Okay, so here both of them I can write it as angle ODA, twice of angle ODA, because both are equal, is equal to 180 degree. So angle ODA will come 180 by 2, we'll get it 90 degree. So if angle ODA is 90 degree, so even angle ODB also will be equal to 90 degree. Right? So that's how we get both the angles to be 90 degree. So that means if it is 90 degree angle, that means OD is perpendicular to AB. Okay, that's what we need to prove. Okay, OD perpendicular to AB, that is what we had to prove. Okay, so this is how this theorem is proved. Okay, this is very easy congruency. You need to know how to draw the diagram for that and how to prove it. Okay, practice this, right? Surely you will get this how to prove. So I hope you understood these theorems, how to prove these theorems. If you found this video informative to you, do subscribe to my channel. I'll be coming up with more theorems, okay, very soon. Till then, take care of yourself and I'll see you soon. Thank you. Bye-bye.